Oh, g'day champions. Anyone who watches my live streams would have sort of been privy of the story on this one. So I'll take you back in time. We'll chop up some of that live stream where I first had a look at this thing, and then we'll bring you back to current day, and I'll show you what it's like now. I've finally finished it. Alright, modified Laney Pro Tube lead head. It really doesn't matter what model it was if it's modified. Nice place to put the Tolex seam. Makes me wonder if they accidentally covered it the wrong way around and that's supposed to be on the bottom. Hey, we got a turret build. Jesus. Oh, so much to take in, champions. So much to take in. Oh, there's an empty socket there with a valve still attached. So it's probably like a Marshall-esque build. We've got 22 nanos everywhere. Some coax, tack soldering. Oh, you got a snapped... Actually, I don't think that's snapped. I think that's cut off. Yeah, bright cap. This weird cloth wire. I've seen this in like Asian amps, like coming from the Transformers. It's got like, it feels like, I don't know, it might be silicon impregnated because it's not sticking to my finger, but two bias caps over here, which are really big for a 10 microfarad 50 volt. Oh, it's a 450 volt cap. Okay, that's why they're big. And that's not required for them to be that big in the bias supply, but it's not going to hurt anything either. Wiring can do with a clean up. And pretty much all the solder joints I kind of want to redo. Active onto the fuse tip and the fuse ring to the power switch, which is good. Got a double pole, single throw illuminated rocker switch there for the power. We could use both poles on that, so instead of going straight to the transformer on the neutral, we may as well switch that as well. It gives you an extra level of protection there in case the transformer goes short circuit or something weird. A lot of mains wiring is just redundancy and making sure that in a certain fault modes you'll still be in the clear. So I'm just going to depopulate everything because the way they've mounted stuff. Well, let's start from afresh, hey? So champions, this is a job, believe it or not. This is an amp that one of my old customers, not old age-wise, but been coming to me for a long time. One of his mates, his bandmates, built it in a gutted Laney Pro Tube chassis, and it's essentially, it looks to me at a glance like basically a 2204 type circuit. So they've used a pre-perforated turret board. They've populated, it looks like they've populated the turrets themselves, or they might have bought this off like one of the Chinese sellers that sells the pre-punched turret boards, just like the no-name ones on eBay or whatever. But they haven't had any idea of how you're supposed to mount things on turrets. So there's always seems to be a lot of confusion as to how you use a turret, right? So people are like, do I put the component up top? Do I put it down the bottom? Do I twist the leads around it? What do I do? Where does the wire go? How do the wires connect? The components are supposed to go in the top of the turret, right? So you can replace the component. You don't generally need to replace wiring unless something's gone really bad. But the components, you need easily accessible replaceability. Now this like goes back to like military stuff. You need to be able to change stuff in the field very quickly, right? Keep killing people more efficiently. So the component leads should be folded over, and I don't put any more than say about 5 millimeters down into the turret, so it's easy to remove. Don't pass it all the way down through and then fold the fucking leads over. We're not trying to make it survive like a missile blast. We're trying to make it so it is replaceable with minimal effort, right, and without having to damage wiring and overheat shit to be able to replace it. But here we've got wires going into the top, we've got wires wrapped around, we've got just random decisions made on every single turret as to which way they're going to do it. So there's no consistency at all within this build. That's led also to overstressed turrets. These are the fork turrets. So they've broken off some of them. So I'm going to replace the broken ones because they're no good to us anymore. You can't reliably put a component in. So we're just going to depopulate everything, straighten the leads out, test the components for, you know, whether they're intolerant or not. I'm going to get rid of the silver micas because they're the shit brand that fail. Silver micas are a joke anyway, just I don't bother using them. People claim there's massive tonal differences. They're very subtle, come on man. It's like Lyle said in the stream yesterday, it's more important what pick you use than what type of capacity you use. and it's much more important who's holding the pick and how they use it. I'll probably go with some Vichy ceramides in those situations. They're very good quality tack soldered stuff all over the place, lots of bare stuff. You may say, yeah, it works. Well, it sort of works, but it's here for a reason, because it wasn't working very well. So let's make it work well. Normally I'd decline this if it was just a, you know, bloke off the street that I hadn't dealt with before. I would have said, no fucking way. See you later. Not even looking at it. Bye. But yeah, because this bloke's a local legend, and he's one of the people that helped me get a leg up when I started in the industry. And he's a working muso, and he's you know, a good bloke. So I thought, let's get into it. So I started thinking, can I just replace a little, like the worst of it? But the further I looked at it, I thought, I can't let this go out. So from now on, I think there's going to be a no project amp policy. I won't be taking anyone's project amp. If you get excited about electronics and you start building something, well, guess what? You can finish it, because that's what I had to do. That's what every other tech had to do. There's no safety nets. Figure it out yourself. Figure it out properly. Take the time. You know, don't just quit and hand it off to someone else. I've had other techs do this. Other techs, guys that make their living, like their sole living off being a tech, give up on one of their builds and give it to me to fix. Like, I couldn't imagine anything more embarrassing than that. I'd die of shame before I fucking did that. Anyway, yeah, so I'm not going to be taking it, particularly other techs' work, because that's shameful. So a lot of this wiring has been stripped too heavily too, so not only have they taken off too much insulation, but they've also set the strippers to the wrong gauge, so they've actually left only 2 or 3 strands left on the wire to solder to, so that's no good to us. That'll have to get cut off. I think we're just going to snippety-doo-dah. These pots are terrible up the front too. There's like 3 that have been replaced, and the remaining 3 are falling apart. Like literally the body of the pot's falling apart. There's the presents one. Check that out. So she's not going to be any good to us. We've got 3 new alphas. We'll check them. What can often happen if they're a bit rough with the with the eyelets there, you can loosen the rivet connection to the wafer, and you get intermittency there. And these 2 just globs of solder, and just, oh, there's another broken lead. Stuff touching other stuff. So it's all got to come out, man. I can't save any of it, because let's look at the situation when you take on someone else's half-finished project. Okay, you work really hard and get it done right. You probably spend more time than you can actually charge for, because literally you're building an amp from scratch, pretty much. So then you've done all that work, and it leaves, and it still has the other bloke's logo on it, and they get credit for your work. People think that sounds awesome and it's really reliable. They go out and buy one, and then that guy gets the money, not me. He doesn't deserve it. So that's one situation. The other situation is you just do what's required to make the thing stable again. Doesn't sound great, doesn't look good, but at least it won't catch fire. Its bias is stable, and there's no intermittency to the signal, right? So now the owner goes around and says, oh yeah, Brad worked on that, Brad fixed it, Brad restored that. But you haven't restored it, you just did what fit their budget. But they forget that, and now they go around telling everyone that you've rebuilt the amp, and the tails get blown out of proportion. And now if anyone ever opens it, go, oh, Brad rebuilt. Oh really? Brad rebuilt this? So now your name's attached to a piece of shit. So you've either got to go full on or not touch it at all. And if you do go full on, you're going to have to live with the fact that that other bloke's name is on it still and not you. So that's why I don't really want to do them, because I kind of lose out no matter what I do. There's no inertia in the job. There's no traction. So you've got a one-off build that you have to spend all this developmental time on, or, you know, reverse engineering the thing. It's not too complicated in this case because it's a common amp, but there's lots of others that aren't so common. And you've got to spend a lot of time, we call it traction, or NRE, non-recurring engineering. That's what you want to try and avoid at all costs. You want engineering or stuff that you can get some kind of value out of in the future. May not be like building and designing things, but for example, these Marshall boards, spent the time to develop the circuit board layout and whatever. Now that time spent, I can just hit go on another order of 100. So that's recurring engineering. That's what you want.
Another 100.
100. Yeah, there's more than that coming, mate. We'll sell those first. I'll buy you a holiday from it first. Do you want to go to Japan again?
Next year?
I think it's September. That's monsoon season. No, we should go to Ireland. Want to go to Ireland?
Yeah.
Or Scotland?
Yeah.
This is how easy it is to sidetrack me. She'll just goes yes to everything because she's a travel agent.
I'm all about holidays.
Can we just go to Vivid first?
Okay.
Where was I? You've distracted me now. So non-recurring engineering is what you want to try and avoid, because you spend all that traction and time and development that you can't reuse. So it's no good to you. So we try and avoid that. I suppose that's where it comes into play, using drop-in boards and stuff. So a 2203 project board, a 2204 project board would be fantastic to just drop in this and then wire it up and away you go. Maybe even pre-populated, you know, but how often does this happen? You know, this exact situation with this exact amp happens once in my whole lifetime. So, you know. So, I'm just going to disconnect everything and rethink it all, which sucks because that means I've got to spend time coming up with a plan, layout, checking maybe if we can reuse this layout or if things need to be changed, and seeing what goes where. And so there'll be a lot of time in doing that. Whereas if I was to just disconnect everything one at a time, clean it up and reconnect it, I wouldn't have to think about the layout, which is tempting. Why am I desoldering? I should just snip. Snippity-doo-dah. Be easy to toss the board and get another blank. Yeah, probably. But that's another thing I'd have to order and wait for, so no. Because if I order something today, it won't turn up till next Monday, even if it's coming from Australia. If you do wrap a lead, don't go more than 180 degrees. You don't need to get it ready for a space shuttle launch. Even they don't. Everyone goes on about military spec wiring, and then you see their amp and there's nothing like military spec. Overbuilt to the point where it's underbuilt, if that makes any sense. It would be nice to order a new board from Evatco. But yeah, I won't see it for a week. Should I give them the surprise of a lifetime that they get it back and it's the Super Lead Overdrive? Oh, man, I'm not going to be able to do this job. It's too time consuming. Maybe I'll just get one of them. Means I can't do anything today. Like everything, I can't fucking do anything, can't finish anything, can't start anything. Everything's got to wait until something else happens, which is out of my control. Spoke too soon. All right. The pile of detritus. In the bin. All right, now what we all need in situations like this.
A big burp.
Alcohol. You can't be good at it. All right, so who's got a good 2204 layout? Lyle, you got one handy? Bloody ink is soaked into... He's drawn with a permanent marker on it, but it's soaked in wherever there was a hole drilled, so I hope it doesn't become conductive. Tight like a tiger. Still loose. I'll get a feel for it in a minute, champions. Bear with me. Time consuming. Just trying to get good wetting on those turrets. For a while there, the turrets from CE Distribution, they really struggled to take on the solder, but whatever issue they had, it didn't seem to be contamination, because I cleaned them with acetone and stuff beforehand, even a bit of Scotch-Brite. It was something to do with the plating. But whatever it is, they've sorted it, because these are taking solder really well, so that's great. One tiny little win this week. Alright, so there's the box of detritus. Honestly, how was I gonna look at look at it, look at it. So those film caps were probably destroyed from heat as well, because they're right there on the joint and just gobbed the solder on there. Those silver mica caps, see, it's got the ASM there. They're no good, so don't use them. They always fail. By the time we've changed all that, and then you got the fork turrets that half of them are broken. It would have taken us longer to try and redeem all of this, and it still would have been subpar. So now with flipping the board over, she looks like a brand new bought one. Bit of a gap there. So much room for activities. Extra stage. Ooh. Anyway. Alright, champions, so welcome back to present day. Well, when I shot the video anyway. Let's have a look at the finished product, and we'll do some sound samples as well. Alright, so starting from V1, we've got some shielded coax there. I've actually used some balanced microphone lead stuff, because it's got 2 cores in the center, which is a little bit more sturdy than the single core stuff that I had, so I just parallel them up, so it's as if it's a single core. Where practical, I've twisted together the wires going to each triode. That actually offers a little bit more stability via the slight parasitic capacitance between the 2 wires being wrapped around each other. On the stock circuit between the cathode and the plate on this V1A, on a stock JCM 800, you find a little 10 picofarad cap, but with the wires twisted around each other, I find that that's not required. So you can see I've redone the heater wire, twisted pair against the corner of the chassis, like I like to do. I run it out of the sockets of 45 degrees, so it's furthest away from each of the pins of each triode. The heater wiring that it came in with has got to be one of the most insane setups I've ever seen, so good riddance to that. I cleaned up the existing speaker jacks and re-soldered all of these joints to make sure there was no fractures. Redid the wiring for the output from the impedance selector and the negative feedback wire there in the purple. Fully cleaned off the sockets, removed all connections, cleaned the eyelets, removed all the flux, flushed out the sockets with solvent. This is all the time-consuming stuff that you don't necessarily see because it's not that interesting. I've upgraded the screen grids to 2.2K. That helps out with the EL34 longevity. I've found the screen grids are usually the first thing to go and take your valves out. It also means that this amp will stand to being dimed even into an attenuator a little bit better than stock with the 1Ks. We've got some flyback diodes on there, R5000Fs from Reticon, I think the company is. Just in the event that you pull the speaker lead out or forget to plug it in, you crank it up, they'll cop the hit instead of your output transformer and your valve sockets. They also offer a nice little place to attach your probes for doing bias measurements and plate voltage measurements and whatever. Got some new Teflon wire there going to the grid stoppers, off to the main board, twisted pair again, slight capacitance helps with the stability. Got a heater elevation circuit here with some local filtering attached to the heater center tap, and that's being fed from the phase inverter node, and that's elevating the heaters by about 50 volts DC. You can see down here I've still got to fill the gaping holes. I've got to make some aluminium plates. I've taken the measurements. I've got to just make them over the weekend or something in the home garage and bring them in, rivet them in place. Maybe a touch of silicon just to stop them rattling. The existing capacitors appear to be okay. They were used, well, they were installed by whoever rebuilt the amp, I believe. I don't think they're from the stock circuit. So got new mains wiring going from active to the fuse tip, fuse ring to the power switch, and neutral to the power switch. Everything heat shrinked and no wires in contact with the secondary anywhere. All the primary wires isolated by themselves with no actual touching of any other circuitry. Everything heat shrunk on the mains, and I've heat shrunk the standby switch too, because that's a great spot for you to just absent-mindedly lean your finger over and touch while you're doing something else. Ask me how I know. You know how I know. I'm a fucking idiot. Moving on. Alright, so we pulled the BIOS off the AC from before the standby switch. Now, it is good to have a switch on the AC because switches can deal with much higher currents and voltages at AC than they can with DC. You'll often see there's an AC and a DC rating on the side of the switch, and the DC is actually shockingly quite paltry compared to the AC, because when the AC passes through 0, it naturally breaks off the arc, whereas DC tries to maintain an arc across air and plasma, and of course that would try to vaporize the contacts. Now this can occur, I mean, it's like a welder. A welder's only a couple of volts, like 10 volts or something, but a shit ton of amps. And it's enough to maintain an arc over a, reasonable distance once the plasma stream is established. But you've seen what it does to a welding electrode, so we don't want that to happen inside the switch. It's a lot easier to break that arc when the signal's passing by through 0 100 times a second. Each time it goes through 0, the arc extinguishes itself and can't reignite itself as easily as it could with the DC voltage across it. Anyway, there's tons of articles on this stuff. Trust me, if you can, it's good to have a standby switch on the AC, but if we pull the BIOS from over here, the start of the rectifiers, what you find is it'll take time for these caps to charge, and there'll be no BIOS supply for a second while the plate voltage is present on the output valves. So by pulling the BIOS from before the standby switch from the AC winding, we're always supplying BIOS to the output valves even in standby mode. These caps are always energized and charged, and when you flick on standby, there's no big pulse of current happening in the output, which can cause like pops and crackles and all sorts of stuff as well. Okay, so a lot of swearing later. You can see we've repopulated the board. We've used the other side because there was still some Sharpie marks on the other side, texture marks, permanent marker. This side looked a bit cleaner, and since we were punching out all the old turrets anyway, we could punch them in from the other side. So it does look pretty good. There's a little bit of texture on those ones too, but that's about the only spot. Starting from the power supply end, we've got 2 diodes in series for each side of the full wave rectifier. Not a bridge, just a full wave with 2 diodes in series on each side. Just splits the voltage across them. They're UF 4007's my preferred general purpose rectifier for everything. We've landed on these values for the BIOS supply, and that is pretty much bang in the middle of its travel, and we're getting right on like 60%, 62% on the output valves. New set of JJ's EL34, so that's fantastic. Got rid of those big silly 450 volt radials that were flopping around all over the place. We've got some nice little V-shays down there, rated at 125 degrees Celsius on these ones. Not that they'll ever get to that because the output valves are way over there. We've got 2 metal film 10Ks here is the next dropper, the dropper for the cathode follower. This is the phase inverter node here, which is where we draw the heater elevation from. Just gone with Panasonics everywhere because that's what I've got in stock. I really like the Panasonics, even though they're not axial. They're they're pretty happy standing up like that, and they're not very heavy. Not like a big orange drop that has to have those big thick leaves to deal with a massive body on the thing. Gone with Yagio half-watt carbon films for most of the signal stuff, and V-Shay 1 and 2 watts for any of the power stuff. I like the V-Shays because they do have slightly thicker leads for longer spans. Like for instance over here, they're just a little bit sturdy. You can see the small signal stuff can move a little bit. It's not too bad because they're only, I don't know, what is that, 40 mil apart, 35 mil. But just the slightly thicker leads helps everything be a little bit more sturdy. Speaking of leads, you'll notice that there's no components wrapped around any of the turrets. Only the wiring is wrapped around the turrets because in theory you shouldn't have to replace the wiring unless something dramatic goes on, as I mentioned in the live stream. But you can easily heat these tops of the turrets and then just remove that component. There's only about 1/4 inch, if that, of lead going down into the turret. So nice and easy to remove if anything should be replaced in the future. Now I've played with the layout a bit. It's essentially a sort of a hot rodded JCM 800 2204 with a few mods inspired by the Dirty Shirley that I built late last year, early over the Christmas break. So it's a few ideas from both rolled together, and I quite like it. It sounds pretty nice. So just a quick look at the front panel. We've gone with burns everywhere except for that one alpha pot there, which was the original. We've replaced almost everything. Probably should have replaced that too, just for aesthetics. So having a look at the front panel, you can see I've gone with a ground bus, basically 16 gauge solid core. These burns pots are actually nice with the long leads there. You can straighten them out and twist them, and because they're thinner and longer than the average pot lead or eyelet, you don't cause damage to the wafer in this area. On other pots that can actually loosen the rivet or crack the wafer if you do that, but on these it's got enough give, and it's also being longer, it can get further away from the main contacts, so no fear of them shorting out. So it's still not great for replacing a pot. You'd have to either cut the wire there and insert a new piece for that section, or slide the whole wire out, which wouldn't be too fun. Ideally we'd have a bus bar up front here, but we had to work with what we had in terms of the boards. So you know, you've seen similar styles on Hoffman boards where he has a long bus bar up the front, which takes care of the ground bus. We've settled on a 1 nanofarad bright cap there. Again, I'll see what the customer thinks of this and we can tweak from there, but I think this is a very good starting point. I think you'll be rather happy with this. I've got 2 new cliff input jacks there. The original ones were pretty manky and the shorting contacts weren't reliable, and they were melted to shit and just looked terrible. So I put some new cliffs on there and just tried to make the wiring as simple as possible and nice and neat. I think I didn't do too badly. Flame me in the comments, you know, as usual, champions. You should have done this, you should have done that, you're a dickhead. What do you even get out of bed for, you know, the usual gear. I'm used to it now. So, it was a very harrowing start to the project, but I'm quite happy with it now, and it is often the case, but the problem is now I've got to catch up with the repair queue, because this has taken pretty much 2 days to do. Often it will be easier to start with a kit. Literally start from scratch and build something from scratch with a kit. JCM800 is a lot shallower than that. You can see the extended wires here, but there's no stability issues with this, so I think that twisting the wires has helped quite a bit. But if you were to build one of these from scratch, gutting an amp's often a bit of a false economy thing. You'd be better off just going to get a kit, or just get some parts from Mojo Tone or whoever, and you're starting off with tried and true stuff. You know everything's going to fit more or less. You don't have to engineer stuff to make old stuff fit new things. And you end up pissing away massive amounts of time doing that, and at the end of the day you end up with a subpar result anyway. So electronically and sonically it's fine, but she ain't the prettiest amp. But you know what, that's probably good, because you can take it to a gig and you're not worried someone's going to steal your shiny JCM800, because everyone knows what that is. Everyone's going to look at this thing and go, what the fuck's that? But then they'll listen to it and it rips, which is kind of ideal. It's a wolf in gerbil's clothing or something. Anyway, enough talking shit. Let's do some close-up shots, some sound samples, and get it the fuck off my bench so I can get on to the 500 other jobs I've got to do. Thanks for watching, champions. Give me a thumbs up. Share it around. Share it to your like-minded mates. And don't be afraid to become a member if you want a little bit of extra bits and pieces. Have a look at my channel. You can see the thumbnails for all the members-only content, and you'll see what you're missing out on. So until next time, rock out with your socks on or something. Take it easy.